Okay, in this video, let's take a look at the multiplicity of the zeros in a function. So, if we get a function like this, what would we do? Well, first of all, in this form, it's impossible to tell how many zeros we have. So therefore, this would need to be factored. So, in this video, I'm not talking about factoring, so I'm just going to write down the factored version of it, which would be fx equals 8x, x minus 1 on the square, x plus 3 on the cube. Okay, and this would be the factored version of this one. And now we can see much better which are the zeros of the function. From here, we can see that one of the zeros is x equals 0. From this part, we can see that another zero of the function would be x equals 1. From here, we can see that another zero would be x equals negative 3. Okay, we have 3 zeros for this function. Now, let's take a look at it. Which one has how many multiplicities? So, x equals 0 is on the first degree. So this has a multiplicity of 1. Now this, x minus 1, is on the second power. Therefore, we will have a multiplicity of 2. And this is basically what it means, that this point repeats twice in this function. We're going to have a 0 twice at this value of x. And x minus 3, x plus 3 on the cube. So therefore, because of the cube, it will have multiplicity of 3. 3. So this is how we see the multiplicities. And now let's take a look at some other examples where we're gonna see how the graph looks after we determined these multiplicities. Okay, as you would imagine, the graph has all kind of twists and turns in it, and the number, and whether it's odd or whether it's an even multiplicity, it will give us a different type of curve on the graph. And that's what we're gonna take a look at here. If you can see, it's roughly the same function, except here we don't have any exponent. X is on the first, x minus 1 on the first, x plus 3 is on the first. Here we all have the same, just like this one, except we raised this middle term to the second power. And here again, all the same, except we raised the last term to the second power. And let's see how the graphs will look. We're also gonna use our knowledge from end behavior in order to determine how these graphs will look. So here we can see multiplicity of 1, multiplicity of 1, multiplicity of 1, right? We have one of the zeros of the function will be 0. Here will be 1, and here will be negative 3. Okay, so let's draw a graph, mark our point. We're gonna have the 0 right here. We're gonna have 1 right here. I'm gonna mark them 0, 1, and negative 3. Let's see, 1, 2, and 3 right here. Negative 3. Okay, now from end behavior, we can determine that if we multiply it out, the leading term will be an x cube with a positive leading coefficient. So therefore, the end behavior from this polynomial, we can expect it to be the front The beginning of it will be looking down, and the end of it will be looking up. So whatever happens in the middle, we know the end will be like this. And let's see. So if it starts like this, that means it will be coming to -3 this way, and whatever happens after 1, it will be going up like this from it. Okay, now let's see what happens in the middle. Whenever the multiplicity is odd, that means the graph will cross the x-axis. Whenever we will have a multiplicity that is even, that means it will just touch it or bounce on it. We'll get to that when we do this one. So let's say at this one we have a multiplicity at -3, multiplicity of 1. So it will not bounce on it, it will simply cross it, the x-axis. But at number 1 we have multiplicity of 1, so it will cross the x-axis. At the 0 we have multiplicity of 1, so again we will have a crossing. So from here the graph will do something like this and will cross the x-axis at point 0. These areas and this area, right now we are simply guessing. You can take some points, plug in for x, let's say -1, -2, or 1/2, to find a better location for this if you want to be more precise. But the exact vertexes of these you won't be able to find right now. When you're gonna go to calculus, that's when you're gonna be able to acquire some skills with which you can pinpoint these locations. So for right now, just roughly draw it in there, and what you know for sure, and behavior, and whether it crosses or bounces on these locations. Okay, let's look over here. Our zeros of the functions are the same, but this time this 0 has a multiplicity of 2. Multiplicity of 2. Okay, let's make the graph. -3, same zeros, 0 and 1. Okay, now let's take a look at end behavior. Right now, if we multiply it out, our leading term will be an x to the 4th, and its leading coefficient will be positive. Therefore, the two ends, the end behavior of the function, the beginning and the end, both will be facing up. Okay, so at -3 and at 1, -3 and 0, I shall say, we have multiplicity of 1. So we know for sure that over here will cross. So let's take a look at it. -3, it will be coming like this. At 0, it will something down here. We don't know for sure. It'll turn around, it'll come to 0. So this one, like I said, we're just guessing. It'll turn around somewhere. It could turn around down here, or it could go a little bit lower. This area we're simply guessing. We get to 0, multiplicity of 1, so we will cross. Now we're gonna turn around somewhere again, and at 1 we have multiplicity of 2, so therefore we know for sure it will touch this point, it will come here, but we have an even multiplicity, so therefore it will not cross. It will simply bounce on it and follow our end behavior, go upwards from here. There you go. That's how this would look. Now let's take a look at the last one. Multiplicities the same, 0, 1, -3. This is the one that has multiplicity of 2. Now, if we graph it, we're gonna have the 0 here, we're gonna have the 1 here, 1, 0, and -3. Now, if we take a look at our leading term, again, it will be x to the 4th, positive leading coefficient, therefore the two ends will be, again, front and back will be pointing upwards. Now, at -3, we will not be crossing, we will be doing a bounce just like here, and at 0 and 1, we will be crossing. So, from -3, the beginning, we know that it's looking somewhat upwards, and after 1, we know it's looking somewhat upward. Now, -3, over here, we're gonna simply bounce, just touch and go back. Now, we're gonna guess that it'll turn around somewhere here. At 0, we're gonna cross, so we're gonna confidently go across it, and again, we're gonna have to turn back to meet this one, and we know at 1 we will cross, and this turn over here, we're gonna simply guess again. So there you go. Whenever you have odd multiplicity, you cross. Whenever you have even, you bounce, or just simply touch it.